Nope, that's a different sound. So, okay. Yeah, so let's see here. It is Friday. We are going into SQL and NoSQL today, right? So relational databases and then also non-relational databases. Who's gone already, like who's touched section 7 right now with SQL? Thumbs up, anyone has? No? Okay, that's okay. All right. So and I'm guessing no one's touched section 8 then yet, right? For NoSQL databases. All right, good. So yeah, so just gotta know it's like those two sections are there. I will say is that I'm teaching kind of both of them today, but you'll notice that I'm focusing mostly on SQL and relational databases. No, not that NoSQL is not important or not used. Like it definitely is used a lot. However, once you kind of know NoSQL, I mean, once you know SQL, oh, that's confusing. Once you know about SQL, looking at NoSQL, it's not like a really huge difference. It's more like the way things are structured. And you'll see that in the lessons in section 8 are like, I think there's like literally a lab and like 2 sections, maybe 3 sections. So it's a very short area. I wouldn't stress too much about trying to like really understand that. So we use MongoDB, which is a NoSQL tool. And there's a whole bunch of like NoSQL basically is like saying like not SQL, right? So there's a whole bunch of other tools, but we use MongoDB at least in the curriculum. I wouldn't stress out about doing that. Even on the SQL part, like it's a very useful thing for data scientists. In fact, there's many data scientists who will say like literally most of my day is writing SQL queries. Is that it's a good thing to know. It's not something, to be quite honest, that we're going to do a lot throughout the whole course. And partly it's just because there's just so much to cover, and to always come back to SQL would just be a lot of effort for us to do. But I'm going to show you guys some basics of SQL. It's not too bad of a language. I think I know Becky has already said that she's had some experience with SQL. Some of you all might have had some, some passing knowledge of SQL too. So just kind of know that that's kind of like a very, like I'll say like it's a useful tool. It's something that I think you guys will find a lot like simpler than like trying to learn Python, even if you've never touched SQL before. Cool. So let me go ahead and just start sharing my screen a little bit. And I have a little Google Doc here. This is mostly for me. Share. So this is mostly for me, just to kind of like go through the different concepts. So what I did literally was like look at the concepts that are talked about in the different section 7 and then into section 8. And I just kind of like, I'm writing my stuff here because I'm going to teach a little bit out of order, but kind of I'm letting you guys see a little bit like what this looks like. Actually, that's okay. I'll just keep things something like this. So we're just going to introduce SQL. I'll talk about like what SQL is, using SQL with Python, writing selections. This is going to be us like actually trying some stuff out. It's going to be a lesson. And then filtering groups, grouping and joins. So aggregation and joins, we'll talk about that together. Subqueries, so we'll talk about subqueries as well. And we'll say a little bit like, what subqueries are. I will mention a little bit about like with statements if anyone's done any SQL before. And then we'll kind of go into, if we have some time, we'll see if we do some exercise or advanced topics. So advanced topics more like, it's like, oh, just more SQL practice. And then I'll definitely talk about this intro right here before we end. And we probably will, I think we might just skip the MongoDB stuff, but maybe if we have time, we'll go into this, okay? Or if someone really, really wants us to go into it, like we can check it out. And then I did mention the SQLite here. So it used to be in the curriculum that we talked about SQLite and talked about something called ORMs. And I'm not gonna talk about that today, most likely, because they do rely on some reliance on object-oriented programming, which some people might, I think actually quite a few people in the cohort do have some experience with object-oriented programming, but if you haven't seen it, it might be a little bit too much on top of all the SQL stuff. So just know that we might come back to this maybe, in the future, maybe into phase 2 and stuff like that, just to kind of show you a little bit. But I'm mostly going to focus all on the SQL stuff. Okay. So let's go right into our intro. So let me go open this link right here. And again, as always, all this stuff is in the repo, right? If you actually find it in the engineering SQL is actually where it is in that like hierarchy. So first things first, like, okay, let's talk about SQL. Like, what is a database? Because it's basically for databases. So a database is really just like a table of data. It's comparable to like a CSV or Excel, but like on steroids. So you can almost think of like, you can even think of like a Excel table like a database in some ways. But a database is a little more powerful than that. It's basically a set of like table of data. So we kind of like used to like, we saw like with Pandas' data frame, or if you're familiar with Excel or a CSV, right? We have a table of data. A database is like, could be like a bunch of different tables. So you can kind of think like, if you are more familiar with Excel, you can almost think of it like, don't quite, but like you can almost think of it like a bunch of Excel sheets that live in a special kind of format. And that's kind of what we talk about. And you might have different information just poured into this database. And usually with a database, if a company is good, what they'll do is they'll make sure to kind of structure their database so that you can relate things back and forth. So we call this basically a relational database. Okay, so we have something called schema, and you can think of schema as like made of tables. Okay, so why would you want to have like all these different tables? There's just like one big like pile of data, which is kind of similar to what some NoSQL is. So one is like we have like I said, relational database basically means that the data tables have relations to each other. So this is generally given to you like by like a business. So like the structure's already there. Depending, on the actual industry you're working with, it might mean that you might have to come up with some of these tables, or you might even add to these tables. Other places you have absolutely no like write access to it. In other places too, you might even not even have complete read access. You might actually have to ask for specific tables to be read and stuff like that. But this schema right here, and people sometimes call this like a schema and stuff like this. This is really just kind of like an organizational chart. Kind of thumbs up. Has anyone seen something like this before? Like this kind of picture? Okay, cool. I see a few thumbs up. So raise hands. Good. More than I usually have, which is kind of nice. Is that this is very typical, like where you might have a structure of like how these different tables are related. So you can see here is that basically each of these boxes is a separate table. So you can see there's a product lines table, a products table, a customers table. And then you can see these different lines right here. These are basically just describing the different relationships between these tables. So it kind of makes sense that product lines and products would be related to each other in some way. And if you look closer inside this like one like table, this like little structure, you can see the name of the table and then like product line, text description, HTML description, image. Those are basically like, you can think of the columns within those tables, right? They're basically the attributes that you'll query along. Say, hey, want this, and or like I want this item. And in a database, in a relational database, we actually will have each item will be filled. So you have like a row, right? Which is your data point, your item. Each item will have every column filled. It might be filled with none, but you are guaranteed that like there is like essentially a value. Like you could ask for what is in text description. There might be nothing in there. It might be like some value of like nothing, but it will be in there, if that makes sense. NoSQL, which we'll talk about a little bit later, doesn't necessarily follow that structure. You might ask for something that doesn't exist for that data point. So just kind of know there's a little bit different. So it's a very ordered, structured data. And you can see here is that like for products, for example, you can see product code, product name, product line. Oh, product line. And basically that's the idea right there. This product line is connected to the product lines table. So instead of having like the full detail, like, product line description, product line HTML description, product line image, like all this information about the product line, you essentially say, oh, the product line number 532. And then it can look into this table and say, oh, for product line 532, what's the text description? And so that's how it's kind of structured in this way. Does that make sense to people? Cool. Thumbs up. Yeah. All right. Cool. We won't go into full detail of every single thing. There's a lot of complicated structures. One thing you can notice right here, you can see that this table for employees actually self-references itself. In this case, you can see there's an employee number, and then there's actually a thing called reports to in this case. And so this is the idea is that there's an employee each row, right? And reports to probably reports to another employee. So that's why it's actually referencing, it looks like, to employee number. Okay, so you can see there's sometimes like self-references and stuff like that. And depending how data, like we can talk about the data engineering database structure. Usually there aren't too many different cross points. Like you will have essentially like one relationship from one table to another table. But depending on like the industry, depending on like the business, they might have their data structure a little different. So kind of be aware of that. Okay. Cool. Sweet. So this brings us to something called primary and foreign keys. So primary key, we'll talk about this, is that basically this is how we structure our different tables and stuff like this. So you might notice this like little like asterisk right there, like next to product line, and then a little asterisk next to employee number. These are basically signaling, in this case, a primary key. And basically the idea of a primary key is that it's actually unique to each data row. So note that this is required for most SQL relationship databases, is that it's actually required. Like there has to be some primary key, right? And so that way you can identify what unique ID. For example, like if you're working in a lot of like finance and stuff like this, and you're talking about customers and stuff, a lot of times their primary, like the unique ID is actually like your social security number. We know for sure, like, no one's going to have the same social security number or, TIN, that's kind of the equivalent. But at least the idea is like, oh, you might have the exact number. Now, of course, and that's a whole different thing. Like, should you have social security numbers in some databases? Like, that's kind of different. But the idea there is like you'd have a unique thing. You wouldn't want to use, for example, someone's first name as unique, as the primary key because it's not unique. So it's going to be an issue of actually trying to reference that file. One thing that might be really useful that you'll see, depending again in the industry, and I've seen in the past, is usually something called a serial. And a serial basically is kind of like just some unique key that's just made on the fly. And essentially it's like just a number. So it's like, oh, like you put a record in there, your serial number, which is going to be the primary key, is number 1. What does that number reference to? The fact that it's the primary key. That's kind of all it is. And so you'll see this a lot with like data. For example, let's say you have a data that's just like, like the person's first name and last name. Well, there's no unique key for sure. Like you could have someone with the same first name or the same last name, or even the same first name, last name, right? So you might need a unique key, and you can bring a serial, and that usually a serial is just something that's a number that just gets counted. So like as you add more records into the table, it just counts up. So, oh, the first record, the second record, the third record will just be serial 1, 2, 3, and so on. Okay. Well, makes sense to people?
I have a quick question.
Yeah.
How is this different from like the index that we've been working on in the
Yeah.
data frame?
Good question. It's basically that when you're talking about like data frames and pandas, right? When you say
Yeah.
index, yeah, essentially that's essentially what that is. It's essentially a serial number as the primary key.
Okay.
So, yeah, if you actually if you look at documentation in pandas, you can actually remove or change the index to be something else. But does rely on that kind of idea of like, say, oh, you have this primary key part. You can really think of like a data frame as essentially like a table. Oh, good question. All right. So now you'll see me say foreign key. So a foreign key is really just basically just a reference to another table. So like I mentioned, like for example, I mentioned on product line, right? Product line going to this table over here. This product line is a foreign key. So it's a key, basically we use this value right here to get, we use this value, which will point to the primary key of another table, okay? So like this will be unique in product lines, but not necessarily unique in products. Does that make sense, people? Okay, so just know that the foreign key basically is the first reference. All right. So that's our structure. It's like, okay, what's this whole thing with SQL? We haven't really talked about SQL. We see out the database structure. So SQL really is just basically a way to like talk to the database and basically saying like, hey, like I want this information from the database. Give me this information. What's really nice about this is that, I kind of mentioned here is like old school, like it's like 1970s is about like when SQL was being used, I think for the first time, is that because I will say, because it's old school, it's really well founded in a lot of industries. Like a lot of places will allow you to do some kind of SQL queries. Ironically, the places that are maybe a little bit newer have to essentially, like they'll still use SQL at some level, but it's really just to use SQL to translate into something like this NoSQL. But what's really nice is that if you do understand SQL, and there's different flavors of SQL and stuff like that, what we can talk about, but that SQL can be like you'll be able to use it pretty well, like across many industries, across many businesses and such. So you can kind of think of like I said, like the intermediary between like you and the database. We'll talk about like what it means like by a query. But when we do a query, you're asking a question. You basically are asking the database saying, hey, like I want this stuff. You write your SQL query. Like, I want this stuff. Can you go get this for me? And the way I describe this is that this was a command language, they call it. And basically, it means that you don't actually, like, to really, really simplify things. When we say a command language, what's really going on here is that you're basically saying, hey, I want this thing, but you, the database, the server, whoever's taking my command, like my program, you figure out the best way to figure it out to return it back to me. So you're not really like, for the most part, most times SQL databases have it pretty optimized where if you do this query, even if you do it 2 different ways, it'll actually optimize to perform the same way. So the way I kind of say this is like almost like you kind of write down, your query, like this is my little analogy. You're sitting downtown, and you're like, oh, I want to ask a query to the database. You write a little SQL query, you hand it off to your messenger, person, your little messenger boy. It's like, all right, send this off to the database. And the messenger person says, okay. And they go run off to the database and say, here's the query. And they say, okay. And they package up, whatever you sent on the command and they send it back to you, right? And so the idea there is like, basically, you're not telling them how to get you this data. You're saying, what do I need from this? So that's kind of the idea of like the command language. Does that make sense to people? Okay, cool. And that's really helpful because in that way you can use, like, even though there's different flavors of like SQL databases, for the most part, you can use the same SQL. Like there's some differences, but you can pretty much write the same exact stuff and not worry too much about who's implementing it. Okay. So who uses SQL? Like I said, you're going to be using this a lot. Like, data analysts use this a lot because basically this is how you can collect data from the database. It's basically already structured. Many businesses in some levels use some kind of SQL database. Like even like I will say, even like the newer, like, think like tech and stuff like this, they usually have some form or fashion that you can actually query with SQL itself. In fact, if you look at the curriculum in topic 7, they actually show you can use SQL, like direct SQL commands in Python data frames. So you can actually say in Pandas, say, hey, here's my SQL query, and treat basically the Pandas data frame as a database or a table. And you can actually collect information like that, which is pretty cool, especially if you're really good at SQL. You can essentially just do that. I personally don't do that too much. I like to think more of the product, the programmatic kind of like how Pandas works. And I won't do that, but like I have known people who just use SQL to query because they're familiar with SQL. So why SQL exactly? Like you'll see a little bit like you might go a little bit like, why can't I just like get all the information, load into a data frame, and then like do stuff? So the real big reason why is because if you just ask a server, say, hey, give me all the records and then I'll figure out the rest, like I'll sort it through. The problem is that might be a lot of information, right? So you have to essentially pull all that data in there into your, whatever computer you have, and then process that information. And then you might get rid of literally millions of records just so you can get to the stuff that you really care about. That would be super slow. It's essentially like equivalent to someone emailing you a bunch of Excel files and then finding the specific records and then just copy and pasting those specific records into a new Excel file. And like it's like, oh, that's really inefficient, right? So the idea here is that it can actually be really fast. Is that you basically make the server do all the work and you say, hey, I want this information. Like I don't care about how you get it. Just like this is what the information I want and give that to me. And essentially you're basically saying, hey, take all those Excel tables. I want to reference this Excel table, this Excel table, and I want these items in those Excel, sheets. Put this in a new Excel table and then email me that. And you can imagine that can be much smaller, much more efficient versus like your computer. And sometimes a lot of these servers, there's redundancies and efficiencies and stuff like that, where it can do it much quicker than even if you load all the data yourself and have the perfect like Pandas data pipeline and stuff like that. It might actually take a long time just because your hardware is slower. So really nice. So basically just use the server to query all that stuff. It's also super common, which is like it's been around since the 1970s, which means like SQL isn't like something really crazy. For the record, I keep calling this SQL. You will hear people call it SQL. There isn't like a direct like, oh, what you should call it. Kind of like data and data. Like you'll hear me say data. In general, I will say it's like people will say data over data, and you'll hear a lot more tech people tend to say SQL instead of SQL. And there's a little bit of a kind of like, it's like, oh, like if you learned it informally, a lot of people will just call it SQL because that's what it looks like. And kind of if you learned it more formally, you'll hear people say it like SQL. But, it doesn't really matter. But just kind of let you guys know that can be pronounced either way. Okay, cool. Any questions about any kind of like this intro stuff? Oh, yeah, Simon, I saw a hand.
So one question. So we are going to do the SQL in Python, all right?
Right.
So is it same as the actual SQL software out there?
Right.
this
So you're saying like
second
if you,
window.
so you're talking more like, because I'm guessing you've used SQL before, right?
Yeah.
Yeah. So if anyone who's used SQL, like you usually have like some program where you type in your SQL query and you like press run and then like would put out your data, right? And like what your results are. It will actually be completely involved in Python. You could do things like that, but we're going to write Python and it's just going to look like code essentially. So it'll keep everything in there. Does that make sense? We'll see this in 1 second once we move on to the next notebook too. Yeah, any other questions? So let's see here. I just want to make sure I'm going to my right one. I wanted using SQL. We just did, yeah, we did. It's a copy. Okay, using SQL. All right, so now we're gonna actually show some code and using SQL. All right, so first thing, you know that there's Pandas, there's NumPy. I'm also importing something called SQLite 3. So this is kind of like going to be our interface with interacting with a SQL database, essentially. I believe the one I'm doing right here is actually local, but know that technically your SQL database, more likely than not, is going to be not on your own computer, right? It's going to be kind of like a request online to another computer, another database. It could be on the same network if you're working, you know, like work nowadays is a little different. But like it might actually be on the premises and you can query and stuff like this. Nowadays, people tend to have things in the cloud, right? So like AWS, GCP, Azure, and that one is basically just, you know, it's equivalent to like, you know, going to a website essentially. There's a request and then it sends you back information. But that is going to look the same no matter what, if you're local or not local. Okay. Cool. So let's go ahead and import these guys. Let's actually start with creating data tables in database. So I'm actually going to actually make a database for you guys first, just kind of show you guys like what this looks like. So I'm actually going to create this thing called connection, right? So I'm just going to con right here, and we have a cursor. So this connection right here basically is going to connect to a database. And in this case, I'm actually going to create a database, planets.db. This is actually just going to be a file that's going to be called planets.db. In fact, I'm trying to move my Zoom little
There's
the
nothing
little
in it.
icon there.
There's nothing there right now.
Yeah,
There's
there should not be
nothing
anything
down
there.
here.
And I believe if I actually, let's just check this out real quick, because I might have already run this a little bit. So let's go to data engineering, go into SQL, and you can see, yeah, you can see there's no planets.db, which is what we're going to write. So when I run this guy right here, this is going to basically create the connection for planets.db. Note that if this was like an outside, you know, like URL or something like that, you would put that in here, so that connection. But this is it. SQLite 3 knows. So you're like, oh, that's just a file. So I'm going to create that, and then this cursor right here, you see connection.cursor. You can kind of imagine like the cursor as being like that's where it's pointing to. I kind of imagine the cursor as kind of like my messenger person. It's like, hey, like bring this off through the connection to the, you know, server downtown, you know, and bring back the results. That's kind of like how I imagine this cursor in here. So if I run this now, though, you'll see, oops, there we go. If we run this now, you should see, there you go, planets.db. And you can see actually there's 0 bytes just created seconds ago, right? So you can see basically just a file. Note that some people, like when they try to write stuff, they'll actually try to open up this file and see what's in it. You're not going to be able to read it. You're not going to have a program read it, because basically it's compressed and like basically made efficient and stuff like this. So you're not going to be able to just like open up and see like what are the different like points in there versus a CSV where you can open up a CSV and see exactly what the values are. The only way to really interface with this is using the SQLite 3, like essentially the format it's using. Okay, so I just want to put that out. Okay, so we created our database. Like, okay, let's put some stuff in it. So we're going to create a table called planets. So this is right here is going to be my cursor.execute. So basically I'm telling the cursor, hey, I'm going to execute this, and this right here is actually a SQL command. And you'll notice that I actually wrote this, it's just a string. So basically we can pass all our commands as strings. So if you're used to, Simon had mentioned, like if you had a program that like you write SQL in, and then you like, you know, have a different program and you press run, and it gives you execution, stuff like this, you could literally copy and paste that into here, right? So that's kind of like one way you can kind of think about it. But what we're going to do here, create table, and note, one thing I should note is that you'll see that I capitalize create table, but this is lowercase. It actually doesn't matter in SQL. Like, and I'm probably going to say something that might be technically not be true, but for most SQL flavors, it won't matter if it's capital or lowercase. I could have this all lowercase and be perfectly fine. And then white space too, you'll see all this white space. I did this basically just for us to read it better, but you could technically write this all in one line, right, with just single spaces, and it would technically run. But I don't like doing that because it's hard to read. Sometimes people write that way, but that's okay. So this create table, as you guys probably say, this is a command right here. That's why I have it capitalized. So this is a SQL command. It's like create table planets. So like, okay, we're creating a table called planets. And then this parentheses right here is saying, okay, this is what's going to be in the planets table. In this case, I'm saying, okay, it's going to be the column called ID. And then afterwards, you see this integer primary key. And don't feel like you have to memorize all this stuff right now. I'm just going to show you guys what this looks like. This is basically saying, okay, here's the name of the column, and here is the type, the data type. So is it going to be an integer? Is it going to be a text? Is it going to be a Boolean? Is it going to be whatever, right? So that's kind of the idea here. And then note that I put primary key to say, hey, this is going to be the primary key. That's how I'm going to look up later on, saying this is a unique value. So I'm just saying primary key, another column name, text, note the commas, another column name, color, text, number of moons, integer, mass, real. If anyone's familiar with mathematics, it's a real number. That's why it's called real. So think of it like floats. That's essentially what's going on here. So it could be negative, positive, decimal. Okay. And then you'll see I end the parentheses right here. And then in SQL, we can, this is actually optional if there's only one command, but this is a terminator. This semicolon basically says, all right, and now I'm done writing my SQL command. This is useful if you write multiple SQL commands. You technically could leave this out and it would be perfectly fine. But just to make things like make sure that's nice and clean, I'm putting this terminator in case, you know, for example, if I wrote a command to create a table and then I wrote a command to insert values in the table, I would have to end it with a semicolon. That way it knows, oh, run this, then run this. Okay, makes sense? Question, Becky.
So the cursor is pretty much telling, like this connects back to planets DB.
Mm-hmm. Yeah, the
So
cursor is kind of like sending that information back and forth.
So you can't just like flatly reference planets DB. You have to create a cursor that acts as the connection between your code and the database you created.
That's right. That's right. Yeah. And this is like, there's a reason for that. That you can get some really complicated stuff where you can have parallelized, you know, jobs and stuff like this, where you can have multiple cursors. This is in general, like at least for most things I would do, I usually just work off one cursor. And so that's why I have this cursor. Good question. Cool. All right, so let's run this guy. And you can see here, it ran through, and you can see here, it actually has a return right here. That's just because it prints out whatever I have at the end. So I could, for example, have like a new cursor, but it just updates the cursor. And so just saying, oh, okay, there's this cursor here. Don't worry about that, you can ignore it. If I put a colon at the end of here, it just won't print anything out. All right, so let's go ahead and check out. So, okay, we have our database in here. There's nothing in it now, so let's actually like do some stuff to it. So first thing is like, oh shoot, I forgot to add this extra column to the table called rings. So I'm actually saying, okay, let's do alter table. So basically say, okay, change the table. It's a SQL command, planets, and then add column. And then I'm adding the column rings. And I'm just saying, oh, rings is Boolean. And you can see there's the end right there. And note that this time I just wrote it in one big line. I could have separated out with space and stuff like that, but it doesn't really matter. Make sense?
Victor, yeah. The beauty of, what I think the beauty of Python is, as I'm learning, is that you can check each step as you go. Could you check that to see that your table looks like that?
Yeah. So I could pull up, like if I went down here to actually like explore in the database, like you could like check the tables, like, okay, what's the table look like, and actually pull that information up. In this case, I'm just saying, oh, I already know what it looks like, so I'm just pulling it up. But yeah, you definitely could, but it wouldn't be as simple as like, you know, just a tab or a print. You'd have to actually use the cursor to say, hey, cursor, tell me what's in the database. And this will be like cure.execute or some kind of command like that. Yeah, good question though. Yeah, normally you probably would go check it just before I added this, but since we already created it, I know it's going to be good. So, but now we got something a little more complicated right here. So this right here is inserting data into the table, right? So I'm doing my current execute again, and then note that these are the 3 quotes, so I can write multi-line strings again, right? And I go insert into, so there's the command, insert into the table planets. And then I'm going to insert the name, color, number, moons, mass, rings. So this is really useful is that you are saying specifically what order you're putting it in the column, in the table. Technically, the tables don't have an order. I know that I take that back. Sorry, they do have an order, but it's usually common practice to think of it as like not an order. You typically it's considered bad programming practice to try to reference it by like saying, oh, I already know the first column is this one. It's usually better to explicitly state, oh, it's going to be this column name. So that's where just know this name as just for each column name. Okay. And then values. And basically each of these rows right here is going to be a row of new data. So note that the name is going to be Mercury, color is gray, number of moons is 0, mass is 0.55, and then rings is 0. And then I have this comma at the end here to say, okay, now I want a new row. Okay, and I'm just going to insert all of these rows in there. Okay, that makes sense to people? Okay. So around that, I note my semicolon just because I'm being extra good, right? Make sure I terminate my commands. If I did keep that off there, it probably would work fine. Create new table. So now I'm going to actually create a similar table called exoplanets. So we already saw a little bit like what we can do. So I'm creating a new table. You can see called exoplanets. And note that I'll show you real quickly. Here. Yeah, I just want to show you that this planets.db, you can see that there's actually data in it now. It's actually not 0. So you can see that just have stuff and right to it. I'm going to create a new table in the database called exoplanets. I'm going to alter that, just I forgot the rings again. I could have put the rings up there, but I'm just showing you guys you can alter the tables. And then I'm going to insert different data in here. In this case, I just made up some big exoplanets in here and with the values. Okay. I should also note that I do have star in here, which is not, I think, related to the first table. Okay, so cool. So I made 2 tables. Sound pretty good? Yeah. Everyone kind of follow me along? Now, for the record, like I personally don't create that many tables. I cannot pull this up from memory. I have to look it up almost every time because it's just not something I frequently do. So don't feel like you have to memorize this too. If you do for your job, end up writing a lot of tables like that, it starts becoming a little more common practice. Back in the day, but like years ago, when I was writing a lot of more SQL databases like this would be like something a little more common. Like I remember, oh yeah, this is how we write tables. I can't remember now. So don't feel like you have to memorize it. Yeah. So cool. We made our tables. Let's actually do the stuff that we normally would be doing a lot in data science, which is exploring the database. So note that here I have cur.execute, and I'm just writing this all in one one line here, but basically it kind of reads like English, right? Select name from SQLite master where type equals table. And you're like, what the heck's going on here? So this is not what we have. So this is actually a special thing in SQLite master. So when we make SQLite, it actually creates this extra stuff just so we can kind of see some information. So I'll show you what this actually executes. So if I run this guy, you can actually see is that this is telling us what tables are in here. So this is really useful if someone tells you, oh, here's the database, and you're like, I don't know what's in it. You can do select, like you can run this command in here and actually get now the names of each table. And you can see it's a list of tables, right? So you can see there's the first list, here's the second list. And note that these are tuples. And you're like, what's like, you can see like, oh, it's a parentheses, right? And then planets is the name. And you see, why is there an extra comma here? It's not because there's like 2 elements in there. It's actually only 1 element in that tuple. It's just to identify, say, oh, this is a tuple. Python puts that extra comma in there to say, hey, this is a tuple, not just like something with parentheses around it. That makes sense to people? I just want to make sure people understood like why there's an extra comma. Okay, so we got name of the columns or name of the tables. Let's go ahead and get a specific name from, get a specific column from a table. So we have select planets.name. So the name is going to reference the column from planets. So planets is going to be the actual name, or sorry, the actual table, right? So from the planet tables, or from the table planets, we're selecting just the name. Okay, and you can see it's .fetch all. And if you run this now, you can see we get now a list of all the names in that table. Make sense? So this right here is what you typically have. So note there's a couple things to break down. So one is that we're actually selecting certain items from like tables essentially. And this is where some people say like, SQL probably could have been written the other way. It should be like from the tables, select this thing. But that's just how SQL is written. So that's how we write it now. So just kind of know that's kind of how the structure of it. Okay. So let's say I want to grab all the records. Like I don't want just the names. I want, everything in here. I could, for example, do this star icon. And basically it's like a wildcard. Just select star from planets. And you'll see now if I run this, it grabs for each row still, but it grabs all the columns, right? For each record. So you can see here, this is the ID itself, right? This is the name, this is the color, this is, I think this was number of moons, the mass, and then like, I think this was rings. So you can see a little bit like, okay, that's where the structure is. Make sense? Cool. All right, you can see something similar now with this cursor execute select star from exoplanets, and note that I have this dot fetch all again. It's basically saying fetch everything, right? So run this guy. You can see all of the data stuff, or all the data points. Now the thing about this is that like this is kind of like, this is nice, but like it's a little like abstract, like not abstract, it's a little vague, right? It's not clear exactly what these reference. So we can actually pull up, for example, the names for each column by doing this list comprehension. And this list comprehension basically says for description in the cursor.description. So that's the real command right here. So this is going to actually return a list where we actually say for each description, just print out the very first thing. And you can see here. Well, let me show you. I guess I'll first show you what happens if I do cursor.description. It's this guy. So you can see here, basically this right here represents like each column in here. But you'll notice that like it gives us extra things like 1, 2, 3, 4, 5. It's a little long. And I think it represents each column. I don't know. I honestly don't really understand why it does this. It must be something it does internally in SQLite. But all I really want is this very first one. So I can write this list comprehension here. And with this list comprehension here, we'll just return this list of column name. Okay. Makes sense, people? Any questions? Okay. Cool. Biggest thing again, cursor.description just will return the column names just in this weird format. So I'm just using this special thing to get that specific name. So it's kind of nice, but like it's kind of annoying to see everything. Like it'd be nicer to have like a function to just do this for us. So you can write your own function in this case. So I actually wrote this little function here called Sql with columns. I can do a query. So this is actually gonna be my Sql query. And then cursor equals cur. So that basically I'm using the default cursor that I created already. Otherwise I can specify a specific cursor. And note that I'm doing some documentation, gives me the full results with columns. The result is equal to query.execute query.fetch all. So for example, if I ran this guy up here, right, it will return this whole thing. Okay, and say, okay, I get the results. Now for columns equals tuple, I'm basically creating a tuple. It could have been a list. I'm using that command basically to get the column names. So it's going to return something like this. And then the full results just to say, okay, my columns plus my results with this return all of the results. This is basically returning a copy. Just know that's why I'm doing this part. And this basically is going to combine the two lists together. So then I get my full result. So when I run the same command, select star from exoplanets, which normally, if I didn't do all this extra stuff, would just return this guy. What it'll return is this guy. So now I can have something like, oh, this is a little more readable and a little more, a little more familiar with like how I might actually look at this data. So now I actually know what the column names are with it. Okay, makes sense. How are we feeling? Thumbs up, thumbs down, sideways?
I have a question.
Yeah, go ahead.
The select star from exoplanets, that's the SQL that says select everything. So why do you then need the fetch all on top of that?
Yeah, good question. So this actually returns, so let's just try this real quick. Let's do, let's just see what it does, right? So if you do cur dot execute, right? And let's just do the same one, select star from exoplanets. Oops. Planets. There we go. Okay, if we just do that without the fetch all, right? Like what happens? Let's just call this R. And let's just print out R. See, the problem is it just returns us basically this cursor item. And if you, for example, do the type, you can see here, it's just returning an actual cursor object. So this is just how SQLite works. So to actually get like the values from it, we can do r.fetch all. And so it's fetching all the results that are from that cursor. And that's actually what gives us this guy right here. So there's technically things we can do like fetch, I think it's 1. And you can see we can get the first result right here. And I think I can actually iterate on top of this just to show you a little bit. There you go. You see, I get the next result, the next result, the next result, the next result. Well, in that case, there's nothing. And then if I do it again, it'll give me an error saying, oh, no, it doesn't. It just says, oh, there's nothing left. So the fetch all basically just gives us all this, but you could iterate it. It's just because you might want to do something fancy with the cursor. So that's why SQLite does it that way. That makes sense, Becky? Good question, by the way. All right. Any other questions?
So the output of the result is also a tuple?
Yeah, it's technically a list of tuples is the result, right? So just to
No,
show
the,
this.
yeah, the result.
Yeah. R dot, let's say fetch. You can see it's still, well, I think it is just, in this case, fetch one is just a tuple. But if I do fetch all, it'll be a list of tuples. So you can see there's the list and then the tuples. Cool. Cool. If I move on then. Yeah. Cool. So let's do some more exploration, right? So I showed some very basic SQL commands. So like I showed you like selecting one specific like column for your results. I can also select specific columns, and note that I can do in specific order. So I do exoplanets.name, color, and number of moons from exoplanets. So you can guess is that when I run this guy, we'll actually see just those columns. Okay, and note that also it depends on the order. So if I go like something like this, you can see the order changes. So it just depends on going through here. Note, I think, yeah, I want to show you one other thing. One thing you can see is that by default, it'll just show like the name, color, like that's the name of the columns. But let's say I wanted it something, call it something different. So for example, I want to call, I don't want to call it name, I want to call it something else. I want to call it like, you know, as exoplanet name. If I run this now, you'll see it actually change. It can say, oh, I'm going to return essentially this, like instead of having the actual column, it'll rename it. And so one thing to note is that technically when you write SQL queries, your SQL results always come back as a table. So it's technically, I'm actually creating a new table here, that just like a temporary table that I can just interact with. Cool, sound pretty good. Sound pretty, doesn't seem too difficult, right? To change from what we just did. Yeah. Okay. I don't think no one looks too confused, so I think I'll keep moving through. Let's bring some more SQL into Pandas. So let's say, okay, I got the SQL, but I want to put it into Pandas because that's like, I like Pandas, right? I actually want to do stuff with it, right? I love my Pandas. So this is like, I say like the clunky way, like how like, oh, you don't write any function, you just kind of just do it, right? So I already wrote, like you can see results equals current.execute, fetch all. So just to break this down a little bit so you guys can see what those results are. You can see if I run this guy right here, you get those results, a list of tuples, right? So if I pass this results into the data frame, and then the columns is equal to, remember that long thing I wrote, this list comprehension to create all the column names. Now I actually have a data frame with, you know, those specific values. And in fact, I'm just going to change this real quick because I know, oh no, I wanted that. Okay. So you can see here, I get the data frame and I can then do whatever I want with the data frame. So again, more convenient that we'd want. And this might be kind of like essentially what you're doing is like, hey, I'm going to send a query, a SQL command. Just want to make sure. Okay, good. I just want to make sure I didn't change the SQL command to something weird that we need later. But I say, okay, here's execute the SQL command, and you know, get it into the data frame. And like, okay, this is fine, but like, man, can you imagine writing this stuff every single time? Like, it seems clunky. I don't know. Like, it just seems a lot more work than I want. I want things like precise and just look at it very quickly and know exactly what's going on. So I'm going to write a function because I just don't like doing things really clunky. So remember that I wrote that SQL with columns, and remember, like, you can see a little bit if I do SQL with columns. You can see I have a little documentation on it. I can't see it because I think it's blocking it. So I actually wrote a little doc string. Right? Give me if I made more, I could have more documentation. But you can see, oh, cool. I can see what that looks like, and now I can go, okay, SQL with columns, SQL command. I can df columns equals results 0 because I know it's full results, and then the result data is everything else. And then that, to me, this looks nice and clean, easier for me to work with. Like it's less likely for me to mess up somewhere where I grab the wrong thing, and you can see here it works. Make sense? Yeah. Any questions? Pretty good. Okay. Cool. So one thing I want to show a little bit is like, you know, what people tend to gravitate where they're not comfortable with SQL. What they'll do is they'll basically try to aggregate everything, like with, like they'll pull all the data and then aggregate it with Pandas versus trying it with SQL. So I'm going to kind of show you a little difference between this. So the first example is going to be aggregating moons. So I'm going to basically, well, we'll see what I'm going to do in a second, is that I'm going to take in, I'm going to basically so get how many planets have so many moons. So like some planets have, one moon, some planets have no moons, some planets have more than one moon. I want to know, like, how many planets have one moon, how many planets have 0 moons, how many planets have, whatever number of moons. So one way I could do this is select, basically get all the data and get my data frame. And you can see there, I get my data frames. And so you'll see here is that I'm going to basically look at, say, okay, like for example, there's 1, 2 planets with 2 moons. Why is Pluto in here? Pluto shouldn't be in there. That's okay. Why is it 2? Sorry, I'm looking back at my past data. But anyway, there's 2 planets with no moons. There's 1 planet with 1 moon. Apparently, there's 2 planets with 2 moons. And so you can see like what I want to say, okay, how many is breaking down this way. So we've seen it a little bit. What we can do this. We can do df.number of moons, value counts. And if we run this right here, we can see, okay, there are 2 planets with 2 moons, 2 planets with 0 moons, 1 planet with 14 moons, 1 planet with 62 moons, and so on. Okay, everyone make sense right here? So cool. The problem with this is that I have to load all the data. So imagine if there's like, I had like exoplanets and there's like literally hundreds, if not thousands, if not millions of different data points in there. I have to get all the data in there and then process it through on my own computer, where maybe at the end of the day, I'll just really have a very small list of things. So that's not super efficient if I have to pull all that data in and do it myself. So one way to do this is actually with Sql. So this way, I can actually do something called aggregations. So this is a new guy right here called group by. So we'll see what this looks like. You can do select number of moons. And then this is, again, this is new stuff, so don't like freak out, right? Is that we have count star as planets count, and then from planet. So this is kind of mostly what we've seen before. This is probably the newest part, this count star. But it's like, okay, we're getting from the table of planets, and we're going to do something called count star here. And the key part is going to be group by. So it's basically going to say, all right, from this table, group by number of moons. So we can kind of remember that group by is kind of like pandas, right? When we did like the group by, we say, oh, group it by, if you have 1 moon, you're one group. Right? If you have 2 moons, you have another group, right? And this count star, basically this is saying count the number of things that are in, and then this star right here, basically just count it. Like, don't worry about what it is. Just say however many records it is, just count that. And so this is actually going to tell us how many are in that group. And then num of moons, basically just saying it's like, it's essentially one of the column names, so we know what that relates to. So now if I run this guy, you can actually see I get now the number of moons. There's 0 moon, like 0. Sorry, planets with 0 moons. There's 2 of them. Planets with 1 moon. There's 1 of them. Planets with 2 moons. There's 2 of them, and so on. So you can kind of see a little bit what this is. And what's nice is that this right here for very large, very large data, this will be a lot easier on your computer because all you have to do is like this very relatively small table versus getting all of the data, filtering it through, right, with pandas, and then getting those results. So instead, you basically make the server do all the work versus like your own computer trying to sweat it out. Make sense to people? Okay, so that's the way you can like do it, and you can see you get the same results at the very end. I could then pass this into a data frame, but you guys get the point. The biggest thing right here is this group by. Just think of a group by like if you're grouping by like as if you did it in pandas, right? If you do group by and then whatever columns you want, that's essentially what's going on here too. Okay. Another example of this is filtering colors. So the pandas way, let's say for example, I just wanted to see different colors and stuff like this. Let's say I just wanted to see the planets that have it looks like blue here. So I can select star from all the planets, getting all the planets in here. And you can see here, I have different colors. In this case, I have blue, right? And then I also have like light blue and then like dark blue, right? So I want all the planets that are blue. So I would have to do is like, okay, results, there's the all results. I have my data frame now and say, okay, now I can say, okay, from there I can use my filter stuff. Say df.color.string, right? So this is basically saying from this column color, and this is called a string. So it's using the string methods in this column, and it contains blue. So basically, oh, does the string contain blue for each of these elements? True or false, true or false, true or false, right? All the way through the records. And then say, okay, get all of that from the data frame, right? And then, okay, display only blue planets with the name and the color. So I'm saying, okay, I don't really care about this extra information, but I do want to show the name and then what the actual color was. So if I do this now, it should show me only those 3 elements right there with the name and the color. Okay. Note that if I just did like this, oops. If I did this, you see I get all the elements in there. But if I want, or sorry, all the columns in there. But if I wanted to specific columns, I could just say all like that. Make sense? Well, everyone followed me on that, Pandas? Yeah. All right, the SQL way, how can you do SQL? This is the whole command itself. So this is where I select planet.name, planet.color, right? So I want the name and the color from the table planets, and then where lower planets.color. So this is gonna lowercase the planets to the planet's color column, lowercase that. And then like, it's kind of like saying equal. That's kind of essentially what it is for string comparison, is equal to. And you'll notice I have blue here, but I have this parentheses, not parentheses, sorry, percent sign. Basically that's saying like everything to the left of it, like I don't care what's to the left of it. There's like something blue, want that. And then I have actually another one right here that says, oh, anything to the right of it. It's like, oh, I don't care what's after that. I just want to see this blue anywhere in that string. Does that make sense to people? Note that if I did take out, it would work actually if I got rid of this percent sign, but it means it would have to end with blue. It couldn't be like blue green. If I had blue green, this wouldn't work. It really wouldn't catch that one part. This is basically allowing me to go either end. Okay. Make sense to people? Like what I did right here? Thumbs up, thumbs down. Nice. Okay. All right. And you can see here, I get the same exact results. And what's nice is that I can just put this in here. And this way I can make the server sort through all the data themselves versus collecting all the data and then sorting it myself. Okay. All right. Any questions?
Yeah, just could I get a quick reminder of what the where is trying to do?
Yeah, so where is kind of like your conditional statement. So they say like a good way to read SQL is almost reading it backwards. Start from like from first, say like, okay, what table am I looking at? So from what table? And then say where, you know, the planets.color, that string is light blue. So this is going to either return true or false, right? And that basically says, okay, just return those records. And then from those records, select these things. Does that make sense?
Okay.
Yeah. So the where is kind of like saying, oh, these are the conditions. Cool. Awesome. And Becky, I think you had a question too.
So I just want to make sure I understand like the overall, like why is SQL faster? It's because SQL always does the where clause first. So it's always filtering down first and then going, and then Python is taking all the data and then filtering, or Pandas?
Yeah, so I should make it clear is that like in a race between like you do it with Python and you do it with SQL, like there isn't a surefire way to know who's going to be faster. Like maybe technically Python can do it faster, but if it takes a long time for you to get all the data onto your computer and then process it, that's more time for you to have to wait for your computer to do things versus like I could have the server do it, and maybe the server has more power, if that makes sense. Then it's just going to give me a small chunk of things. So instead of downloading, I'm just kind of like giving an example, like pretend it's like not on my own computer and it's somewhere else. It's like 10 gigabytes, 100 gigabytes, a terabyte of data somewhere else. Instead of downloading all of that data and then doing something with it, I can tell the server, hey, I just want these things. It can do all that work sorting through that information and then passing it over to you. So that's kind of like why it can be faster.
So the where happens on the server, and that's
right.
Why it's faster sometimes.
Yeah. Essentially, it's like it's faster because we're telling the server to do the work. We're basically telling someone else to do it, which technically, for the record, could technically be slower, but usually the SQL servers are pretty fast. And usually the slow part is not necessarily even the sorting part. The slow part is like just getting all the information. So again, like you said, the where is going on the server, doing its thing, and then serving us up the result. Cool. Good question. Simon, do you? Mm-hmm.
So what is the limit of the SQL? I'm trying to ask in sense of the data size. Like we have a big data programming language as well, right? For example, Pig. So I think Pig and SQL is pretty similar. And
Right.
What is the cutoff? Do you have any idea?
Yeah, so this is where it gets complicated. And in short, it depends on the implementation and like, are you actually talking to a SQL server, or are you actually talking to something that's actually not SQL, but it's translating it in from SQL from NoSQL? We get into these really kind of like more data engineering questions. In short, the limit is basically due to something you don't usually have to care about. That's kind of the idea there, is that you rely on the people who created the database, the data engineers and stuff like that. You can rely on that, like they know what they're doing. And so you can just get that more efficiently and stuff. But there are limits and expectations. For example, for the record, we'll talk about nested like queries or subqueries, we call them. There technically is a limit on some subqueries, but the limit is like so ridiculous that you never reach it. Like I think the limit is technically 256, like nested queries within queries within queries within queries. If you ever reach that limit, you're doing something wrong, right? But there's those kind of limits that you usually have to worry about. There are limits on the hardware itself, right? So like you could have, for example, like talk about NoSQL in a bit, but SQL relies on having essentially one server, one computer that does all the work. And in some applications, that's perfectly fine. But for like obviously really big data, like that's not going to work. There's no one computer that can process all of Google's data, right? Or all of Twitter's data or whatever, right? It's just too much. And so that's when people start moving towards NoSQL. And NoSQL can kind of what we call like parallelize that and distribute that information and work in a different way. But what's nice is that usually you can still use SQL as a data scientist to pull that data, even if it's not really a SQL like database, a relational database. That kind of answers your question. Like again, it didn't really answer your question, but hopefully that kind of addresses what your might be concerns for it.
Yeah, sorry, it was just out of context. I was just.
That's all right. No, it's good to ask those things. I will say for the record, like there are people who get paid a whole lot to make sure these servers like run well, and their whole life is around like the server and stuff like that. So know that you can, like as a data scientist, implement these things. But I would say like if a company says, hey, I want you to do all of these things, I would kind of like stay away from that unless you like felt really confident and have a lot more background in actual like server and like standing up all that stuff and networking, because they can get pretty complicated. But yeah. Cool. Any other last questions? And otherwise we'll move on to the next part. You go ahead, Bill.
Yeah. What's the difference between Sql and Sqlite?
Yeah, so SQLite, it's just basically like another. I'm sorry.
In the beginning of the chapter, you import the module is Sqlite. So I don't
right.
ask, yeah.
Yeah, we're talking about like this right here, right?
Yeah, right here.
Yeah, so SQL is kind of like, how do I say this? SQL is kind of, it's different from Python in the sense that when we talk about Python, it's like, oh, it's Python. SQL's kind of got more of a fuzzy definition of like what exactly is SQL, and there are different flavors of SQL. And it's not, because the language is a command language, it's not so much about how you write it, it's more about like how it's implemented on the database itself. Is that we'll usually talk about SQL as like the thing that we interact with the relational database itself. But SQLite, in short, SQLite 3, SQLite is an implementation of a relational database that uses SQL. And so this can be common, like, you know, for example, I can use SQLite 3 to write a small little database on my computer itself. You can basically interact in that way. But you could also use SQLite not just to implement a database, but also use it to actually connect to a database. So I actually put something like here, like, you know, note that you can connect to a database over the network, depends on the system. So for example, there's something called Postgres Sql, and Postgres is kind of another flavor of SQL, but we can use like, you know, for example, something like my user, my secret, like my password, and then like, you know, the actual like path to the database. And I can still use SQLite to interact with that. And I don't have to actually like use it to create anything. So it's just a package essentially that can do a bunch of things, which is can create certain flavors of SQLite, and then also, of different flavors of SQL like databases, and can also interact with other relational databases. So that makes sense, like that difference.
But the command we are dealing with is the same, no?
Yeah, like in short, like the actual command is probably going to be very similar, if not exactly the same, depending on, like, you know, it's slightly different depending on what kind of relational database you have. For example, I used to use DB2 with IBM, and DB2 has some weird quirks that are not in the same as the most common SQL version. Well, I'd say it used to be the most common. MySQL is usually really common across many industries. But now, even now, it's like Postgres Sql is pretty common across the order and stuff like that. But the SQL commands are relatively the same. There are some slight differences, but usually they're very slight, and you can pretty much use the same SQL commands.
Thank you.
No, good question. I love hearing all the questions because you guys have some good ones. It makes me have to think sometimes. Okay, cool. So, all right, we got about 30 minutes left. All right, cool. So that's good. I showed you a whole bunch of stuff. So let's go through here. I'm actually going to skip over to, well, okay, let's see what database lessons are real quick. So this is their lesson. So I might do more of the kind of walking through a little bit versus like actually trying to run some of this stuff and everything. So we're just going to kind of skip through it because some of the stuff we've already seen. So I talked about SQLite 3. Okay, so this is a database right here I already have called data.sqlite. And I'm actually going to create the cursor there and run this guy. Oops, I have to actually import stuff. There we go. So the reason why I just do ls here, you guys know you can write little commands, command line stuff. So you can see ls. I can see there is, where's SQL? There it is. There's my database. So I'm going to use this database called data.sqlite. I'm going to load that on that connection, have that cursor, and then I can create some queries right here. So for example, you can see select name from SQLite master where table or type equals table. We saw what that is. That's basically to show us what tables are in there. So we haven't looked at this database yet. So you can see here, there's an order details table, a payments table, and so on. In this results, I'm just going to grab the very first result, for example. You can see here it's order details, table names. I can get just all the table names now by doing from the results res or R and getting just a table name right each time. You can see here I get all the table names now. Okay, so good. All right, I can get all the table names. I can play around with that. So like, okay, let's see. The first thing we want to do is like let's select everything from the employees table. So okay, let's get everything from employees. So you can see that's the table, and not this limit 5 at the end here. Just saying, oh, just don't keep going forever. Like, just give me just 5 results. So you can see here is that I can actually, these are each of the elements actually return. And you can see here, it looks like there's 1, 2, 3, 4, 5, 6, 7, 8 columns, right? For the table employees. And I can get a feel for this. It's probably like their name, Murphy, Diane. I don't know what this is exactly, you know, I'm gonna figure that out later. You can see there's the email in here, and there looks like there's some number, some extra stuff. President looks like maybe something like, you know, their position in the company. So you can see really quickly without even looking at the table description, I can get a feel for like what's in here. That's what I'm doing right now. So let's go check out some extra stuff. So let's say I don't want to type all this stuff. Let's see, I'm pretty lazy and I don't want to type. Think of how much you have to type to get relevant information. So for example, if I wanted to get like all this relevant information, I have to go run this stuff right here, display the results. And then I say, okay, like, well, I can see the results. Like, what does that mean? I have to look at the descriptions, look at all that stuff. We saw like how kind of annoying this is, like look and compare the stuff. This is where I wrote this function here. So it's the same function as last time. And I can see here, it's like, okay, let's select start from employees. And then I can look at my results, and you can see here, now I have a little bit cleaner, right? I have the employee, the column names in that table, and then the results from that table, right? And you can see there's quite a lot of results. So, okay. And it's not even that many results, like 10 results, I think. So anyway, so okay, like let's go through like a little bit easier. We can see the description. Okay, we can see the items. Okay, like this is better, but like we can do one step better, which is that SQL to DF. So basically, I'm using this guy right here to create the data frame like we saw before. So I'm just running this guy, and you can see here, there we go. We actually have this employee number, last name. Oh, okay, like extension. That's what that, you know, X5800 is. So you can see a little bit clearer of like what's going on, and this is probably more familiar with what you like to use as a data scientist. Okay, so cool. So like I mentioned before, you don't want to load all the results directly into your data frame and then filter it through because it can be really slow. So again, like you kind of want to think about in those terms. Sometimes it's not that many records, you can probably do it. But if you can think more in SQL, this usually will end up being faster and help you in the long run of actually writing SQL queries. So we get some queries with joins. So actually trying out some stuff like from multiple tables. So we haven't seen this yet. So one, I can actually select things from like order details. So I can see here's all the order details. Here are the products. Let's move this out away from me. You can see is that here's the order details, here's the order products, and you can actually see, I think I can see it in this just column because there's not that many. I believe there is a, where's the shared product code? Okay, so you can see product code. There you go. So this shared right here 2 keys. product code right here, right? And then the product code right here. So note that this basically is showing like orders. Like you can imagine, like this is basically what's been ordered from customers, and this is actually showing like what do we have in the store itself. Okay, does that make sense between order details versus products, right? Cool. So now it's like, okay, we want to combine this information together. For example, this is cool. I can see like, this is the order number. This looks like this is a bunch of orders from the same order, or sorry, a bunch of products from the same order, and you can see the quantity. But the product code is not really meaningful to me. I'd like to be able to see this all at once versus like trying to like dig through and say, okay, what's S18 underscore 1749 and have to search this table to find that. It'd be nice to just combine it together. So we can actually do that with a join. So we can combine it with something like select star. So remember, select star is going to return everything, but we're actually going to do it from these tables. So from order details, and I can use something called join. And we can remember this is kind of like combining these tables together. So actually you can say order details join products. So we're going to combine these tables together, but like, how do we combine it? How do we know they match up? We want kind of like one line, right, between each table. And we can say, well, on order details, so order details dot product code is equal to products, that table dot product code, because those two keys right here, or these keys, these two columns match up with each other, and that's how we can reference together. So basically we essentially say, okay, combine it with, they have the same product code, just combine those parts together. And so I run this guy, and you can see now I have order number product code that still exists, but now you'll see on the far right here, you'll see the rest of the table, which gives me the product name, the vintage line. Note that product code is still included in there because it was part of that original table, and I said select everything from it. So know that now this table is really nice and big, and it's a little more beautiful. Okay. Does that make sense to people? This is the main guy you gotta pay attention to.
I assume you could write something to remove one of the product codes?
Yeah, you could. You're saying like, drop like, don't include this guy right here?
Well, wherever there's a duplicate, sure.
Right, yeah. Yeah, so in that case, I can actually specify very specific things, which I think I show in a second. And so I'll show you guys what that looks like. Because the thing is now, if I say like, I'll show you what might happen. I don't know if this will actually work. It might actually fail, which is good. So I run this guy here. You can see operational error. And basically what's happening is that ambiguous column name, it doesn't know this product code, that column, does that relate to order details or from products, right? It doesn't know which one to grab. So the way we have to do this now is actually writing explicitly what, column name for what table. So for in this case, like I told you, like try not to read this first, read this one first, because we say, okay, from, we can see order details as OD, and this is called an alias, right? So you can remember how we do as like a column name. I can say, oh, order details, OD is going to be referenced to order details table. And we can see join products as P is going to be the products table. And that way I don't have to write order details products. It just makes, I don't have to type as much because I get lazy. And then we can do the same thing. So it's going to join on OD, which is order details dot product code equals P dot product code. So that's nice and easy. And now it's like, okay, once we combine this together, now I just want to show the order number from order details, the product name from product, products, and then product code from products, the quantity ordered from order details, and then the price of each from order details. And you can see I gave it specific names. Note that if I have spaces, I have to use quotes, right? Otherwise I could just write it out like this. However, note that this one right here, you notice like, why did I have to write quotes around here? That's because order actually has, it's a reserved word in SQL, and it won't like this, it'll get angry at you. So note that you have to specifically say, oh, this is order, which is in, just using quotes, okay? And then note that we also did some kind of fun thing right here. We can actually do some math. So you can see the price of each times the quantity ordered, multiply together and create that as a total, which kind of makes sense. Like, oh yeah, if I have how many was it, like how many did I order? And then how much did each one cost? I want the total. And I can actually create this guy right here. Okay. And so I just copied and pasted that, run this guy. And now you can see here, I got a nice little data frame that has my order, right? It says what the product is instead of that product code, right? And I have my product code here, quantity, price per unit, and total. And now I have something that looks closer to like an invoice. Make sense to people? I went through that really quickly, but any questions? Cool. So the biggest trick right here is using this as for the table, is that I can now use an alias, right? So I don't have to like type out all the products. I could have technically like products and then order details is super long, but I get lazy. I don't want to do that.
So what kind of join is it? Because in Panda, I remember we had like inner or outer.
Perfect question. So like what kind of join? There's inner join, there's outer join, there's left join, and there's right join, which no one uses right join. I mean, I don't use right join. Join in general, if in SQL, if you don't say what kind of join it is, it's by default an inner join. So that means that in this case, note that we could have technically lost some order details, right? If there was no product, like for whatever order it was, it didn't have a product code, like maybe like it's an outdated products table. It would have dropped it, right? It would have just not included that in the list. So that's actually something important to note too, is that this will actually only look at thing if they both are in both tables. But yeah, it would be an inner join by default. Note that if I typed in to say what kind of join you want, you just do inner join. And that by default will do the same thing. So you can see join and inner join in SQL is actually the same thing. But I can just type it out inner. If I want to do something else, I could do something like outer join, left join and stuff, and we'll see that in a second. Yeah. Any other questions? All right. So perfect segue right from Samana saying like, like, hey, what about, if you had different joins like that? Well, let's check that out. So pulling up this database or this notebook, I'm gonna use the same database as before. We've already explored a little bit. I'm just loading up some functions that I've done so I don't have to like rewrite all that really crazy stuff. We talked about the order details table, right? Which has, let's just check out some information, has about, all right, was it 2,996 different order details, right? And you can look at products and let's check out the products table. Oops. And you can see there's about 110 different products, right? At least in this table. Okay. So now if you go back into actually joining it, right? Let's do an inner join. So we do an inner join like we did earlier. You can see here I just did join, literally the same exact code, except in this case I just select everything. This basically is like, oh, this is some funkiness because now we have product code. So I'm just gonna rename some stuff. So I'm not gonna go through this whole detail, but if you look into it, I'm basically just going through and renaming the different column names and stuff like that. So what it looks like now is like I can say, oh, o.order name, o.product code. That way I can reference it directly and know that this product code belongs to order details, not products. Okay. Not really important, but just you can look at that later. Okay. So if we look at this now, we can see, okay, we have 2,996 items. Okay, looks pretty good, right? So one thing we might want to consider though is like if there's a product, like I said, like if we did a left join, there's something missing and stuff like this. So a left join allows us to say, okay, everything in this left table, the table before we join it, include everything here, and if there's something missing on the right, just fill that in with null, like a null value essentially, right? So if we do this now, if we do query select, right, this left join instead of inner join or join, that will basically create a left join. It'll make sure to include everything from products, right? Let's see, it'll include everything from the products table and fill in with the order details. If there is like, for example, a product in here that is not included in order details, it'll just skip over that order detail, but we'll keep every product in there. So for example, if there's a product that was not bought, let's say someone never bought, whatever product, then it will still include that in the list, but it just won't have any order details on it. Does that make sense? Okay, so if I run this now right here, I'm just renaming columns. So just make it more specific. And you can see here, here's all my products. And remember, originally I had, oh, I did an inner join. Did I do an inner join? I think I wanted to try to do an inner join here. Sorry, I'm just doing inner join first just to show you like what happens. If I do inner join here, remember there's 110 products, right? So like, okay, it looks pretty good. If I do left join, if there's nothing missing, what we'll see is that, remember there is 2,996 different values. This should be the same if there weren't anything missing. But if you look at this, oh wait, you can see here, I got an extra data point right here. So remember it was 2,996. And with the left one, I got an extra record. So it's including one of the products on there, which didn't have an associated order details, right? So I got all the order details fine, because it matched the same number, but it was missed. Like if I wanted to actually list the product numbers, right? You can see here is that there was actually a product that was not actually purchased. And that's what I explore next. So what if there are no orders for this product? I just want to show you like, okay, like that means there might be something missing. So I'm gonna actually look at this inner join that we just did up here and say which one's null. I'm sorry, I should say left join. I don't know, I call it inner join here. And you can see, oh, here it is. You can see here is that this was never bought. So you can see there was no record in the order details for product S183233. So this is a way you can kind of pull like, oh, there's some missing data, or not missing data, but like there were no instances where someone bought, whatever this product is, 1985 Toyota Supra. So cool. And you can see if I were to check, I was going to go check this. I can see if this existed in the last join. For example, if I did inner join instead of left join, you'll see is that if I actually try to connect this now. Oh wait, sorry. If I look at, what I'm trying to get at is that if I check this guy right here, that's how I want to do. Sorry, I'm trying to think of what I want to do, but that's okay. The point is that we're missing a product in there because no one bought it. Okay. So that's kind of like what you can do with joins, and be careful with joins. In general, you'll probably do a left join versus an inner join unless you want to only include 2 attributes. Usually you'll do left joins. They are considered a little more safe because you always get the same values. We already did aggregations. I just wanted to show you a little bit. We can do a group by, right, with product code, right, and do count.sort values. And you can see here, we can see how many products were bought for each one. So just now I separated this out just to make it easier to read. We've done group by before. I'm getting just the product name, .count, .sort values. So I see the most common ones that are being bought. We can do the same thing with SQL. I can do select this product, right? Count star. So remember, we always should start with this from part. So from order details, I'm joining it on here. And then saying, okay, group by product code. So I'm basically saying, okay, from the order details, how many, what group it by the product code. And then I'm going to order by product count. This guy right here. So you should read this as essentially from order details, joining it together, group it by product code, then select the product code from products, and then just count how many records are there for each group, and just call that product count, and then just order it by product count. So this is a new one right here. But if I got rid of this, what would happen is that it just shows me, oops, df.head. Let's just do df. You can see here, it shows me right here, but it's not necessarily ordered. You can see it's not out of order. So if I actually include order by, it'll actually order by the product code or product count. You can see here now, it'll show me 24 down 53. So note that by default, this order by does do descending. If I want to do ascending, or sorry, it goes, yeah, it does by ascending by default. I can do DSC, and that will give me it by descending order. So, and I'm going through a lot of quick stuff, but the main thing is just mostly practicing it. You're probably gonna get that mostly from the labs and such, but kind of show you a little bit what's being done. Okay, any questions on that? Any questions at all? Because I know we're technically at time now, and so I kind of want to just talk about Nosql, but I wanted to make sure you guys, if you guys had any questions about SQL in general, you guys had those answered. All right. I know we had a couple other things, like I had SQL exercises and advanced topics. That's okay. There are in the notebook just some advanced stuff. You can see execution order. We didn't talk about subqueries. Maybe we'll talk about this another day. Just no subqueries in general just means that you have a query within a query. So you can kind of like reference, like you can create one table, like you can create like, for example, I made this like table over here of like products in orders together. I can then use that table essentially as like a table that already exists in the database. So I can like query off of this. So that's what subqueries allow you to do. Cool. So let me go into NoSQL real quick, and we'll maybe spend like maybe at most 10 minutes on this. I know it's a little bit over, but I think we'll be okay. Right. So NoSQL. So like, what is NoSQL? So the joke usually is like, is SQL just not good enough anymore? SQL databases are relational databases, and they're really built for like tabular data. Think of anything that you would put like on an Excel file, you would probably put it like in a SQL database. That's kind of the idea here. So it's really focused on being structured, which can be useful and safe, but it's also super restrictive. Essentially what happens is like you essentially have to know what kind of structure do you want in your database before you actually start populating it with data in there, which can be super useful, especially if you're an old industry, old business that already knows exactly what they want, and you can make sure it's really safe and structured and know where everything is. But if things change and stuff like that, you essentially have to create a new database, or at least, at the very least, a new table. Or I've seen a lot of places, businesses will create new funky tables because they have some new information that they didn't account for, and they didn't want to change their database, and they just made a new table that was a weird reference table. So it's a little more restrictive. So that's where like NoSQL, or not only SQL, comes in. Basically allows for non-relational databases. Sometimes we call these distributed databases. And so the idea here is that NoSQL allows for these things called like non-relational. Basically means they don't rely on like having the relationships predefined ahead of time. You can kind of add different stuff, and they're different. I put a little link in here for AWS. Actually talks about a lot of NoSQL and like what that looks like. There's basically a lot of different ways to implement this. So it's kind of a nice thing. So advantages of this is that you don't need to know the structure when you start. Basically, you can kind of go as you flow, like go through it. So it makes it really flexible compared to like a database, like a data warehouse, a database where a relational database. It's something called horizontally scalable. Has anyone heard that term before? Horizontally scalable. Basically, it just means is that if you have like, if you need more processing power, or if you need more space, instead of like if you have a relational database, you essentially have to keep it on one server and it has to live on there. Well, you're limited by the hardware then. If there's a very, very large database, it's just not going to fit on one server. It's just not possible. So what you can do is basically have it more distributed by horizontally scale. So basically, instead of having one server, you have many servers that are just not super, they could be super powerful, but they don't have to be monolithic, like, oh, this is the super strong server. And there's a whole bunch of advantages of that. And depending on what the goals are for the business, they might have different, like they might use a different implementation of NoSQL. Like one reason why you might have multiple servers is for redundancy. So if in case one server goes down, you still have the data afterwards without having backing up the whole thing. I was with a company for a while. I was working with a company for a while, and they were getting to the point where they had, the SQL database, and they had one server, and they would do a backup every day for regulatory reasons. And their backup was ending up getting closer and closer to 24 hours. So their backup was getting to the point where literally their backup wasn't fast enough to back up. They'd have to they would have to essentially start bleeding into the weekend, of their work week and stuff like that, which was like, IT was not very excited about that. So one good thing about distributed databases, you can have more of this kind of distributed, where if one server goes down, there's still that redundancy in information. Other cases where you might have distributed stuff is like, if you want more real-time application, where if you have one server and it can only accept so many people asking for information from it, it's going to get bogged down, or it's going to limit people, say, hey, you can't, come in, you have to wait for me to have resources. If you have more of a horizontally scalable system with NoSQL, you can essentially have, it's like, oh, more people are asking for me, asking for this information, just open up a new server and they just send them to that new server over there. And that's relatively easy in non-relational databases versus relational databases. And this is actually why the cloud has been really good at this, because you can essentially spin up a new server on the cloud and not have to worry about like making this whole monolithic kind of thing. You can just make a small little instance. For the record, this is kind of similar to like, if you hear things like Docker and containerizers and stuff like this, that's kind of like what it is, kind of the extreme version of that. But anyway, that's what the big advantage of NoSQL is, basically this horizontal scalability. And also the fact that you don't need to know the structure ahead. So some example systems I'll just kind of go through. MongoDB, so that's the one that the film talks about, but there's also Google's Bigtable, and then AWS's DynamoDB. So those are also NoSQL, and then Apache Cassandra. I see a lot of Cassandra out there. Bigtable is actually, we'll talk about maybe this in the future. I've used this a lot just because GCP just honestly has anyone used AWS by chance? Like either passing stuff like that? I see Chuck. Yeah, AWS is like, it's good, but like it feels sometimes very engineered. I have to say Google Cloud Platform, GCP, a little bit like nicer UI, probably because they have to compete with AWS's like very engineered kind of feel to it. But basically know that these are kind of like, especially Bigtable, and I didn't put it on here, but well, no, I did put on here, DynamoDB. Those are two like related kind of things, but they always do NoSQL. Just kind of quick thing, like, how does this all work? You have different data model types. So how NoSQL actually works, you have something called either document, like these are different ways you can do NoSQL. So there's something called document stores, and a document store basically is you have a document that says the structure of what these things are. They're more hierarchical. So you reference the document and say, oh, what's this document? like what is this document will tell you what the structure is. And that's kind of similar to how MongoDB can kind of work. You can use a document to say, hey, this is the structure going on here. Key value stores. So it's kind of like a dictionary, right? It's kind of, we call it a hash table when we're not talking about Python. But basically the data is partitioned where you say, oh, here's my key and here's my reference to that key. So it's kind of like you can almost think like a primary key for data, but it's like even more powerful because you don't have to know what the value is on the other end. You can say, okay, like in the primary key for like a relational database, you know what the other columns are, but in a NoSQL database, you can have like maybe some columns that exist in some data points and other columns that don't exist in columns anymore. But basically you have other keys aren't in other data points. So for example, maybe some instances of your employees, they have something like, reports to, but maybe there's other ones that just don't have reports to because it's just not relevant to them. You wouldn't have that included and you can actually just pull that up as you need it. So it's less structured, but it means more flexibility. There's also graph databases. So these are much focused on like the relationships of connecting stuff like this. This is useful for things like social networking, fraud detection. So basically how people interact or what their transactions actually interact with. Recommendation engines, knowledge graph. These are more special case for the sense that like they focus on the connection between like the relationships between different data points versus the actual data points themselves. So the databases are basically optimized for that specific part. So those are like three of the main like different ways of doing NoSQL. I'm sure there are other ones that I don't even know about, and I'm sure there's going to be other things that like are going to come in the future as like people find use cases for it. RDDs, you'll hear people talk about this. Fault tolerance and resilient distributed databases. I have a missed photo opportunity here. I should get my babies and just get copy and paste. They do actually have a little shirt on there, but basically the idea with RDDs is that you have multiple servers. So multiple servers. So basically the idea there is like if something fails, you can have redundancy. This is actually a really great, like there's a little course on Hadoop, which is a way of doing RDDs, another NoSQL database. Has anyone heard of Hadoop by chance? No. So just know that Hadoop is a little more old school. People tend to focus on Spark. That's kind of the similarity of Hadoop and Spark. But it's still really used in a lot of industry. Facebook still uses Hadoop, for example. I just don't find a useful reason to go to Spark. We'll talk about this in the future with MapReduce and big data stuff. But basically, there's a redundancy where essentially not all the data lives on one server, but it's spread out enough where if one thing goes down, is inaccessible, or a fire happens, you can still access other data, and there's redundancy in that. Okay. Cool. And that was my real quick spiel of like NoSQL and everything. Any overall questions about NoSQL, or I don't know, if anyone's heard about it before or had something like pop in their mind about it? No? Cool. The good thing is I will tell you about NoSQL is that usually there are some SQL ways of referring to the data. So you don't have to, sometimes you don't have to actually go into like say, oh, how do I actually reference these things? But if you want full efficiency, you probably will have to go into that specific like database structure and like how do you actually query things out, which is like MongoDB, which if you do section 8 or topic 8, you'll see that in there. Come on, did you have a question or comment?
So one question, so are we going to be able to, or are we going to have to apply all of this SQL, non-SQL, or any of this in our projects, or is it just for us for knowledge?
Yeah, to be honest, you really don't have to do like for our program, we don't focus too much on SQL, NoSQL. Like to be quite honest, if you like pretty much forget all of this, like for the whole course, you'd be perfectly fine. However, I will say is that it's good to refresh on, especially as we get closer to like searching for job search, because SQL is one of those things that is, it's not gonna, again, like for the most part, most people are gonna be like, oh, do you know SQL? I was like, I kind of do. And if like, they'll probably be fine with that. But it does help you the more you kind of know about that. So if you do already have SQL underneath your belt, you're in a good spot. If you're like worried about like learning about all this stuff, plus on top of everything else, like don't stress out about it. It's just like another nice thing to do. I would probably like, what I tell people like as they get closer to like graduation is go back to like literally topic 7 and like practice those labs and see if you can kind of reproduce some of those labs. This is where people like say, like, they will ask me things like, oh, like what kind of resources did you learn to learn SQL? And I literally cannot tell you where I learned SQL from. It's one of those things that I just ended up having to do because I had to do it. and that's just how it becomes knowledge. And in general, I tell people, like, I don't know, like a lot of people are in the same boat as me. I haven't heard too many people say, oh, this is the resource to do SQL, because it's just been around for so long. I don't know, maybe it's just not really a big thing, but yeah, anyway, I wouldn't stress out too much if you like feel like, oh, I need to learn all this stuff. Becky, you have a question?
Yeah, can you define the difference between RDDs and distributed databases?
Yeah, so RDDs, like their main focus is about the redundancy itself. So like the resilient part of it, like that's what you can kind of think of, like that's the real, like, I mean, that's literally like in the name, right? Distributed data sets versus resilient data sets. The idea for RDDs is really trying to focus on something, making sure that there is a redundancy built in, so that if someone either, like, I talk about, like, you know, it being in a fire, but it could also just be like there's too many people asking for, you know, information, is how can they get other information from it? And that's where you get things like map reduce and stuff. Distributed databases don't necessarily have to be resilient. They're just distributed. So there could be, for example, like, I'm just going to make up something. There could be only be like, you know, 10 people who work on this database, but they need the performance, you know, for that. So they might have a distributed data set or database versus a resilient database. You have some extra things in there where, you know, for example, if you run like an internet company like Twitter or whatever, right? And you need to pull up the tweet for something that, you know, people are going viral, and you need to keep track of how many people are liking or retweeting and stuff like that. You need to like have that redundancy in there, because the problem is that you can't send all the information to one server, like as an overflowed. So the idea there is you have it spread out, and then you have something called like eventual, oh my gosh, I'm blanking out. Eventual, I'm missing the word for it. There's a technical term. But basically the idea there is that there will be eventually the data will be reflective once all like the dust settles and all like the high velocity items are going through. So what you might see, I don't know if anyone's like a really avid Twitter user, but if you ever go on Twitter, like I say Twitter because it's the most obvious one, is if you look at it, they'll have like little update of like likes and retweets, but you'll see it fluctuate in a weird way, going up and down, up and down, up and down all the time. And the reason why is because of basically RDDs, where basically it's like, oh, it's sending it out to different areas, and eventually it's going to just keep track of everything that's being done, and then eventually it's just going to come back together and say, oh, this is the source of truth. So in short, is RDDs really just talking about like the resilience of it, like saying, and mostly we're talking about things like redundancies and stuff, but distributed databases don't necessarily have to be an RDD. That makes sense. Cool. I saw a thumbs up from Becky, so I think that's how that answered it. Mark, did you have something you wanted to ask or comment on? I saw you unmute, so.
Oh.
No? Okay. I just wanted to make sure. Cool. Any other last questions? More comments? No? Good. Cool. Well, I will stop the recording here. You go ahead and stop.